Welcome back to Cosmos in a Pod Space and Astronomy series. You know, it's a question we've all probably pondered at some point while gazing up at the night sky. How does it all end? What's the ultimate fate of the universe? Well, today we're diving deep into those big questions.
It's a journey that takes us from the tiniest particles to the largest structures in the cosmos. And it forces us to grapple with some pretty mind-bending concepts like entropy, dark energy, and even the possibility of a cyclical universe.
Okay, so let's unpack this a bit. To understand where we might be going, we kind of need to look back. Way back to 1929. That's when astronomer Edwin Hubble made this groundbreaking discovery that the universe isn't static, it's actually expanding.
Yeah, Hubble's observations were truly revolutionary. He found that galaxies are moving away from each other, and the farther they are, the faster they're receding. This was the first concrete evidence that the universe is dynamic, not fixed.
So the universe is kind of like a balloon being inflated, right? Everything's moving further and further apart. But here's where it gets really interesting. This expansion isn't slowing down, as you might expect. It's actually accelerating.
Right. How does that even work?
Yeah, that's what I want to know.
Well, that's the million-dollar question, or maybe the trillion-dollar question, considering the cosmic scales we're talking about. The driving force behind this accelerated expansion is what we call dark energy. It's this mysterious force that makes up about 68% of the universe's total energy content.
Dark energy. Okay, that sounds a bit ominous. Is it this dark energy that holds the key to the universe's fate?
Well, it's definitely a major player in this cosmic drama. You see, the ultimate destiny of the universe boils down to this cosmic tug-of-war between dark energy, which is pushing everything apart, and gravity, which wants to pull everything back together.
Oh, okay, so it's a battle of cosmic forces, and depending on who wins, we get a different ending to the universe's story.
Exactly. And based on our current understanding, we've got two main contenders for how it all might end. Heat death, also known as the Big Chill and the Big Crunch. Let's start with heat death.
The Big Chill. Okay, that doesn't sound very cozy. What does this heat death scenario look like? Paint me a picture.
Okay, imagine a universe that's been stretched so thin, it's essentially a cold, dark void. The expansion continues relentlessly, galaxies drift farther and farther apart, eventually becoming isolated islands in a darkening cosmos.
So, like ships passing in the night, never to meet again. And what about all the stars? Do they just keep twinkling forever?
Sadly, no. Even stars have a lifespan. They eventually exhaust their nuclear fuel and die out. Even the longest living stars, the red dwarfs, will eventually fade away, leaving behind remnants like white dwarfs, neutron stars, and black holes.
Okay, so even the stars eventually go dark. But what about those black holes? Aren't they supposed to be, well, forever?
Even black holes aren't eternal. Over mind-bogglingly long timescales, they slowly evaporate through a process called Hawking radiation, a mind-bending phenomenon where black holes actually emit particles and lose mass.
So even these cosmic behemoths eventually fade away. Everything just dissolves into nothingness.
In a sense, yes. In this heat death scenario, the universe reaches a state of maximum entropy, where everything is spread out and there are no more energy gradients to drive any processes. It's a state of equilibrium, of perfect stillness and uniformity.
Wow, that's, I don't know if depressing is the right word, but it's certainly a bleak ending. So the universe ends not with a bang, but with a whimper, a slow fade into cold, dark nothingness.
A rather poetic way to put it. But remember, we're talking about processes that unfold over trillions upon trillions of years, timescales so vast that they dwarf the entire history of the universe as we know it.
Okay, well, that gives us a little time to adjust to the idea, but seriously, it's a lot to wrap your head around. Okay, let's switch gears and explore the other contender, the Big Crunch. This one's got to be a bit more exciting, right? A little more drama to end the show.
It's definitely a more dramatic scenario. Instead of endless expansion and cooling, the Big Crunch envisions a universe where gravity ultimately wins the tug-of-war. Imagine the expansion slowing down, halting, and then reversing, everything starting to fall back inwards.
So instead of drifting apart, everything starts crashing back together. That sounds a bit chaotic.
It would be a cosmic demolition derby on a grand scale. Galaxies would collide, stars would be ripped apart, and the universe would get denser and hotter as it contracted.
Okay, so instead of a big chill, we get a big oven. Everything gets cooked as the universe shrinks. Where does it all end up in this scenario?
Everything collapses back into a single, infinitely dense point called a singularity. It's essentially a reverse Big Bang, where all matter and energy get compressed into an infinitesimally small space.
So we end up back where we started. A cosmic reset button. That's a wild thought.
It is, and it leads to some even more mind-blowing possibilities. For example, what if this big crunch isn't the end, but rather a new beginning?
You're talking about a cyclical universe. Like the big crunch triggers another big bang and the whole process starts all over again.
Exactly. It's a fascinating concept that some cosmologists have proposed. In this model, the universe goes through these cycles of expansion and contraction, with each big bang creating a fresh start.
So it's not really an ending, but more of a cosmic rebirth. That's definitely a more hopeful outlook than the eternal void of heat death. But we're getting a little ahead of ourselves. Let's go back to these two main scenarios, the big chill versus the big crunch. Is there any way to know which one is more likely?
That's where the mystery of dark energy comes back into play. It's the wild card in this cosmic game.
Okay, so let's talk dark energy. What's the latest on this enigmatic force?
Well, as we mentioned, dark energy is currently driving the accelerated expansion of the universe. And if it continues to behave as it is now, the heat death scenario seems more likely. But, and this is a big but,
Oh, I love a good but. What's the catch?
the catch is that we don't fully understand dark energy. We don't know if it will always behave this way, or if its strength might change over time. What if it gets stronger? Or what if it weakens?
Okay, I'm all ears. Let's explore those possibilities. First up, what happens if dark energy gets even more powerful?
If dark energy intensifies, it could lead to a scenario called the Big Rip. And trust me, this one is even more dramatic than the Big Crunch.
The Big Rip. Okay, now you've really got me intrigued. What exactly goes down in the Big Rip?
And imagine the expansion of the universe going into overdrive, accelerating at an ever-increasing rate. This runaway expansion would eventually become so powerful that it would start to tear apart everything in its path. Galaxies, stars, planets, even atoms themselves. It's the ultimate cosmic shredding event.
Okay, that's officially terrifying. So it's not just a slow fade or a fiery collapse. It's like the universe gets ripped apart at the seams. Everything gets shredded into, well, what? What's left after a big rip?
In the Big Rip scenario, the universe would essentially be reduced to a sea of isolated elementary particles, unable to interact with each other due to the extreme expansion. It's a pretty bleak ending, even compared to the heat death.
Wow, okay. We've gone from a cosmic graveyard to a cosmic shredder. I'm starting to feel a little claustrophobic even though we're talking about the universe. Okay, let's explore that other possibility you mentioned. What if dark energy weakens instead of getting stronger?
If dark energy weakens, gravity could eventually regain control. And if that happens, we could be back on track for the Big Crunch scenario, everything collapsing back inwards towards a singularity.
So it really is a cosmic tug of war, with the fate of the universe hanging in the balance.
Exactly. And the key to figuring out who wins this battle lies in understanding dark energy better. It's one of the biggest mysteries in modern cosmology.
I'm sensing a theme here. Dark energy is a bit of a troublemaker, isn't it? Throwing a wrench into all our neat and tidy theories about the universe's fate.
You could say that, but that's what makes cosmology so fascinating. We're constantly trying to piece together this puzzle of the universe, and every new discovery often leads to more questions than answers.
Well, I'm hooked. This has been absolutely mind-blowing so far. But before we get too lost in the cosmic weeds, I think we need to take a quick break to process all this information.
Agreed. We've covered a lot of ground, and we still have plenty more to explore.
We'll be right back to continue our deep dive into the fate of the universe, so stay tuned.
Welcome back to our cosmic exploration. Before we went on a journey to the end of the universe, we were discussing those two major contenders, heat death and the Big Crunch, with dark energy holding the reins.
Yeah, it's a lot to ponder, right? I mean, these scenarios play out on such vast timescales, it's almost hard to grasp.
It certainly challenges our human perception of time. But think about it this way. Contemplating these cosmic endpoints actually helps us understand our place in the grand scheme of things.
Okay, yeah, I see what you mean. It forces us to kind of zoom out and look at the bigger picture, beyond our everyday worries and concerns.
Exactly. And when we do that, it highlights just how precious our existence is, even if the universe itself might eventually fade away or collapse.
It's a good reminder to cherish the time we have here and now, wouldn't you say?
Absolutely. And to appreciate the incredible beauty and complexity of the universe we inhabit.
Well said. Okay, I want to go back to something we briefly touched upon earlier.
Yeah.
The cyclical universe idea. The concept that the Big Crunch could lead to another Big Bang, starting the whole cosmic dance over again. That one really captured my imagination.
It's a captivating idea, isn't it? This concept of a universe that goes through cycles of expansion and contraction, death and rebirth.
Yeah, it's almost like a cosmic heartbeat. But is there any actual scientific support for this idea, or is it just a philosophical musing?
Well, it's definitely more than just a philosophical notion. There are a few cosmological models that propose a cyclical universe. One of the most well-known is the conformal cyclic cosmology, or CCC, developed by the renowned physicist Roger Penrose.
Okay, so tell me more about this CCC model. How does it work?
Well, Penrose's model is quite complex, but in essence, it suggests that our universe isn't a one-off event, but rather part of a potentially infinite cycle of expansion and contraction, or eons.
So each eon ends with a big crunch, which then triggers a new Big Bang, creating a new eon.
That's the basic idea. Now, here's where it gets really interesting. Penrose proposes that information about the previous eon might actually be encoded in the cosmic microwave background radiation, the afterglow of the Big Bang.
Wait, are you saying that there might be echoes of previous universes embedded in the very fabric of our own universe?
That's precisely what Penrose suggests. He believes these echoes might manifest as what he calls Hawking points, faint circular patterns in the CMB.
Okay, that's mind-blowing. But I have to ask, is there any actual evidence to support these claims?
Penrose and his colleagues have identified some potential Hawking points in the CMB data, but these findings are still debated within the scientific community.
So the jury's still out on whether there's concrete evidence for a cyclical universe.
Exactly. But even if we haven't definitively proven it, the idea itself is fascinating. And it speaks to the power of human curiosity to explore the most profound questions about the universe and our place within it.
Yeah, it definitely makes you think, doesn't it? The idea that our universe might not be unique, that there might have been countless universes before ours and countless more to come.
It's a humbling and awe-inspiring thought. And it reminds us that even with all our scientific advancements, we're still just scratching the surface of understanding the true nature of the cosmos.
Okay, so we've explored the big chill, the big crunch, and even the possibility of a cyclical universe. But I'm curious, we've been talking about the universe as a whole. What about our little corner of it? What does the fate of the universe mean for us here on Earth?
That's a question that naturally arises when we're contemplating these cosmic scenarios. I mean, if the universe is eventually going to freeze over or collapse in on itself, what does that mean for life as we know it?
Yeah. It makes you wonder about the point of it all, doesn't it? If everything's just going to end anyway?
I understand that feeling. But I think it's important to remember that the timescales we're talking about are so vast, they're almost incomprehensible to us. Billions, even trillions of years. Humanity will likely have faced countless other challenges and transformations long before the ultimate fate of the universe plays out.
So you're saying we shouldn't let the existential dread of the universe's ending stop us from living our lives to the fullest.
Precisely. Our time here is precious, and the fact that we exist at all in this vast and mysterious universe is something to celebrate.
I love that perspective. It's a reminder to focus on what we can control. Our own actions, our relationships, our contributions to the world, rather than getting bogged down by cosmic anxieties.
Exactly. And it's also a reminder to cherish the beauty and wonder of the universe while we have the chance to experience it.
Well said. You know, speaking of understanding the cosmos better,
Yeah.
there's one more mind-bending concept I want to touch on before we wrap up. The multiverse. Have you heard of this idea?
Of course. The multiverse. The notion that our universe might be just one of many, perhaps an infinite number of universes, each with its own unique set of laws and properties.
Okay, I have to admit that one's always sounded a bit like science fiction to me. Are we talking parallel universes, alternate realities, the works?
Well, the multiverse concept encompasses a wide range of possibilities. Some theories propose that new universes are constantly branching off from ours, creating an ever-expanding web of realities. Others suggest that universes exist in higher dimensions, like bubbles in a cosmic foam.
Cosmic foam. Okay, now you're really speaking my language. But is there any actual scientific basis for these multiverse theories? Or are they purely speculative?
It's a very challenging concept to test, but there are some tantalizing hints from areas like quantum mechanics and cosmology that suggest the possibility of other universes.
So we're not just making this stuff up. There's actual science behind it.
There's a growing body of theoretical work and some observational clues that seem to fit with the multiverse hypothesis. But it's definitely still an area of active research and debate.
I have a feeling that in cosmology, everything is an area of active research and debate.
That's a fair assessment. But that's what makes it so exciting. We're constantly pushing the boundaries of our understanding, exploring new ideas, and searching for evidence to support or refute those ideas.
Well, I, for one, am eager to see where the journey takes us. But for now, I think we've reached the end of our deep dive. We've explored the end of the universe, pondered the mysteries of dark energy, and even ventured into the mind-bending realm of the multiverse.
It's been a fascinating journey indeed, and I hope our listeners have enjoyed exploring these cosmic questions with us.
I'm sure they have. And I want to thank you, our expert guide, for sharing your insights and knowledge with us today.
It's been my pleasure.
Welcome back to Cosmos in a Pod. We're nearing the end of our deep dive into the fate of the universe, and, it's really made me appreciate the sheer scale and mystery of it all.
It is awe-inspiring, isn't it? To think that we, these tiny beings on this little planet, are able to even contemplate the ultimate fate of the cosmos.
It really puts things in perspective.
Yeah.
We've talked about these grand scenarios, the big chill, the big crunch, even a cyclical universe. But before we wrap up, I wanted to circle back to something you mentioned earlier. The idea that even though the universe might have an end, that doesn't diminish the importance of our existence here and now.
Yeah, that's a crucial point to remember, I think. Sometimes when we confront the vastness of space and time, it's easy to feel insignificant, but it's important to remember that our lives have meaning and purpose, regardless of what might happen to the universe billions of years from now.
Yeah, I love that perspective. It's a reminder to focus on what we can control, our actions, our relationships, our contributions to the world, rather than getting bogged down by cosmic anxieties.
Exactly. And it's also a reminder to cherish the beauty and wonder of the universe while we have the chance to experience it.
Well said. So as we conclude our deep dive, what's the one key takeaway you hope our listeners walk away with?
I'd say the most important thing to remember is that the quest to understand the universe is an ongoing journey. It's a journey fueled by curiosity, observation, and a willingness to challenge our assumptions. And even if we never find all the answers, the very act of searching expands our knowledge and deepens our appreciation for the cosmos.
Beautifully put. And on that note, I want to thank you, our expert guide, for taking us on this incredible journey through the mysteries of the universe.
It's been my pleasure.
And to our listeners, a huge thank you for joining us on this cosmic adventure. We hope you've enjoyed exploring the fate of the universe with us. Remember, whether the universe ends in fire, ice, or something even more extraordinary, we have the incredible privilege of being a part of this grand cosmic story. So keep looking up, keep asking questions, and never stop exploring. And if you enjoyed this deep dive, be sure to follow and subscribe to Cosmos in a Pod for more explorations of the universe. Until next time, keep wondering, keep exploring, and as always, keep looking up.